Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the refrigerants and heat pump system. Let's firstly talk about the refrigerants. When designing a refrigeration system, there are several refrigerants from which to choose, such as chlorofluorocarbons, hydrofluorocarbons, hydrochlorofluorocarbons, ammonia, hydrocarbons, carbon dioxide, air, and even water. The right choice of refrigerant depends on the situation at hand. Isoether was the first commercially used refrigerant in vapor compression systems in 1850, followed by ammonia, carbon dioxide, methyl chloride, sulfur dioxide, butane, ethane, propane, isobutane, gasoline, and chlorofluorocarbons, among others. R11, R12, R22, R134A, and R502 account for over 90% of the market. The industrial and heavy commercial sectors were very satisfied with ammonia and still are, although ammonia is toxic. The advantages of ammonia over other refrigerants are its low cost, higher COPs, more favorable thermodynamic and transport properties, and thus higher heat transfer coefficient, greater detectability in the event of a leak, and no effect on the ozone layer. The major drawback of ammonia is its toxicity, which makes it unsuitable for domestic use. Ammonia is predominantly used in food refrigeration facilities, such as those used for the cooling of fresh fruits, vegetables, meat, and fish, refrigeration of beverages and dairy products such as beer, wine, milk, and cheese, frozen of ice cream and other foods, ice production, and low-temperature refrigeration in the pharmaceutical and other process industries. R11 is used primarily in large-capacity water chillers serving air conditioning systems in buildings. R12 is used in domestic refrigerators and freezers, as well as automotive air conditioners. R22 is used in window air conditioners, heat pumps, air conditioners of commercial buildings, and large industrial refrigeration systems, and it offers strong competition to ammonia. The ozone crisis has caused a major stir in the refrigeration and air conditioning industry and has stripped a critical look into the refrigerants in use. Refrigerants that are friendly to the ozone layer that protects the Earth from harmful ultraviolet rays have been developed. The once popular refrigerant R12 has been replaced by the chlorine-free R134A. R22 is being phased out because it is ozone depleting. R410A and R407C are among the common alternatives to R22 in residential and commercial air conditioning and refrigeration applications. R410A is the most common refrigerant for new installations due to high efficiency and no global warming potential. R502, a blend of R115 and R22, was the dominant refrigerant used in commercial refrigeration systems, such as those in supermarkets, but its use has been discontinued. Several replacement options to R402 are available. It was realized in the mid-1970s that CFCs allow more ultraviolet radiation into the Earth's atmosphere by destroying the protective ozone layer and thus contributing to the greenhouse effect that causes global warming. Prolonged exposure to solar ultraviolet radiation can cause serious health effects on the skin, eyes, and immune system. As a result, the use of some CFCs is banned by international treaties. Fully halogenated CFCs do the most damage to the ozone layer. Two important parameters that need to be considered in the selection of a refrigerant are the temperatures of the two media with which the refrigerant exchanges heat. To have heat transfer at a reasonable rate, a temperature difference of 5 to 10 degrees centigrade should be maintained between the refrigerant and the medium with which it is exchanging heat. If a refrigerated space is to be maintained at -10 degrees centigrade, for example, the temperature of the refrigerant should be remain at about -20 degrees centigrade while it absorbs heat in the evaporator. The lowest pressure in a refrigeration cycle occurs in the evaporator, and this pressure should be above atmospheric pressure to prevent any air leakage into the refrigeration system. Therefore, a refrigerant should have a saturation pressure of 1 atm or higher at -20 degrees centigrade in this case. Ammonia and R134A are two such substances. Let's now talk about the heat pump systems. Heat pumps are generally more expensive to purchase and install than other heating systems, but they save money in the long run in some areas because they lower the heating bills, despite their relatively higher initial costs. The popularity of heat pumps is increasing. The most common energy source for heat pumps is atmospheric air, although water and soil are also used. The major problem with air source systems is frosting, which occurs in humid climates when the temperature falls below 2 to 5 degrees centigrade. The frost accumulation on the evaporator coils is highly undesirable since it seriously disrupts heat transfer. The coils can be defrosted, however, by reversing the heat pump cycle. This results in a reduction in the efficiency of the system. Water source systems usually use well water from depths of up to 80 meters in the temperature range of 5 to 18 degrees centigrade, and they do not have a frosting problem. They typically have higher COPs, but are more complex and require easy access to a large body of water, such as underground water. Ground source systems are also rather involved since they require long tubing to be placed deep in the ground where the soil temperature is relatively constant. The COP of heat pumps usually ranges between 1.5 and 4, depending on the particular system used and the temperature of the source. A new class of recently developed heat pumps that use variable speed electric motor devices are at least twice as energy efficient as their predecessors. Both the capacity and the efficiency of a heat pump fall significantly at low temperatures. Therefore, most air source heat pumps require a supplementary heating system such as electric resistance heaters or an oil or gas furnace. Since water and soil temperatures do not fluctuate much, supplementary heating may not be required for water source or ground source systems. However, the heat pump system must be large enough to meet the maximum heating load. A heat pump can be used to heat a house in winter and to cool it in summer. Heat pumps are most competitive in areas that have a large cooling load during the cooling season and a relatively small heating load during the heating season. In these areas, the heat pump can meet the entire cooling and heating needs of residential or commercial buildings. The heat pump is least competitive in areas where the heating load is very large and the cooling load is small. Okay, that's all for this task. Thank you very much, and see you next time.